This video will cover measuring waves and the law of reflection. Both are topics found in a typical physical science class, and both have mathematical formulas that would need to be solved. Now let's begin with measuring waves. When we measure waves, we will be looking at three components: velocity, which is the speed of the wave as it moves forward; frequency, which will be measured in hertz; and then wavelength, which will be measured in meters. Now, with regards to measuring waves and using this formula, this is a simple algebraic problem where two of the components will be given and the third will be solved for. The only difficulty is that these problems are typically word problems, and thus one needs to identify the components and then plug them into the equation to solve for x. So if we take our velocity, our frequency, and our wavelength, we will see that velocity or speed equals wavelength times frequency. Now do remember that speed or velocity is measured in meters per second. If we take that equation and rearrange it, we can see that frequency will equal speed divided by wavelength, and frequency is measured in units of hertz, and wavelength, which will be in meters, will equal speed divided by frequency. Now do remember that the symbol for wavelength will be the lambda symbol. So let's look at an example problem. A tuning fork has a frequency of 280 hertz, and the wavelength of sound produced is 1.5 meters. We want to calculate the velocity. Now we're calculating the velocity, so we would come up and we would use the equation speed equals wavelength times frequency. We are told that our wavelength is 1.5 meters. We are told that our frequency is 280 hertz. So we would have 1.5 meters times 280 hertz. We would do the math and we would get an answer of 420 meters per second as the velocity of the wave. Let's look at a second example. A wave is moving towards the shore with a velocity of 5 meters per second. If its frequency is 2.5 hertz, what is its wavelength? Now as we come up here, we will use the equation wavelength equals speed divided by frequency. We are shown that our speed is 5 meters per second and that our frequency is 2.5 hertz. So we will take our 5 meters per second divided by 2.5 hertz. We do the math and we will get 2 meters as our wavelength for this particular problem. Here we have a problem dealing with earthquakes. An earthquake produces a wave that has a wavelength of 417 meters and it travels 5,000 meters per second. What is its frequency? Well, again, if we have our formulas in front of us, we will know that frequency equals our velocity divided by our wavelength. We are given a velocity of 5,000 meters per second. We are given a wavelength of 417 meters. So we take this, divide our 5,000 by our 417, and we would have a frequency of 12 hertz. One final example before we move on. Find the velocity of a wave in a wave pool if its wavelength is 3.2 meters and its frequency is 0.6 hertz. Now the key to this is just to have your equations in front of you so that you know which equation to choose in order to solve the problem. In this case, we are asked to find the velocity, and so we know we will use the equation velocity equals our frequency times our wavelength. Now we are given our wavelength as 3.2 meters. Our frequency is 0.6 hertz. Therefore, we take these two numbers and multiply them out, and we would have our velocity or speed as being 1.92 meters per second. Now let's review over the law of reflection. The law of reflection states that the angle of incident equals the angle of reflection. Now what this means is if we were to take, say, a flashlight, and when we take this flashlight and we were to shine a light at a flat mirror, we would see that that light hits the mirror, and this area where it hits the mirror is called the incident ray. Likewise, that light is going to reflect off of the mirror surface, and that's going to be known as the reflected ray. Now, because this mirror is flat, it represents 180 degrees. But if we were to imagine a line coming up, and that's called the normal line, that divides the mirror in half, we would have a 90-degree angle right here, and we would have a 90-degree angle right there. Now, where we have our light coming in as our incident ray, that area between the where the light comes in and where we have the normal line is known as our angle of incidence. And then we have that light being reflected off. And that area where the light is reflected off, in between where we have the normal line, that is known as our angle of reflection. So if we come down to this picture down here, we would see our angle of incident, which would be where our light ray comes in, and we would see our angle of reflection, which is where the light ray bounces off. Now right here we have our mirror representing our 180-degree surface, and we divide that in half with our normal line, and that would represent a 90-degree angle here, and that would represent a 90-degree angle right there. Now we know that where our incident ray comes in, we have an angle formed between that incident ray and our normal line. That is our angle of incident. And then we have our reflected line, and we have an angle that's formed between our reflected line and our normal, and that is our angle of reflection. Now, the law of reflection states that the angle of incident is equal to the angle of reflection. So if we know this angle, we will likewise know this angle. Now we also know that the angle of incident plus this remaining angle right here must equal 90 degrees. So if we know this angle right here, we would know this angle right here. And likewise, if this angle is equal to this angle, and we know this one, we would know this angle right there. So what we're going to do is we're going to look at how this would show up in a typical physical science problem. So here we have our example problem. Light is incident on a flat surface, making an angle of 10 degrees with the surface, as shown in figure A. Now, what is the angle of incident, what is the angle of reflection, and sketch the path of reflected beam on the diagram. So let's begin with this right here. Now we know that this right here is our mirror, and then we draw our normal line. And we know that our normal line is perpendicular to our mirror, making this a 90-degree angle. We know that this angle right here is 10 degrees, and we know that because it was stated over in our problem. So if we know this right here is 10 degrees, we would take 10 subtracted from 90, and that would give this angle right here as being 80 degrees. Now, if we know our angle of incident is 80 degrees, because of the law of reflection, we would know that our angle of reflection would also be 80 degrees. And so as we draw this out, we would come over, and what we would do is we would measure up 10 degrees from our surface here, and we would draw that out, giving this a 10-degree angle and giving this area right here an 80-degree angle. Now if we come down here, you'll see that drawn out.